Okay, what page are we turning to? Page 14. No, not page 14. Page 14? Oh, no, not page 14. We already did that one. Yeah, 16. And I think I, by mistake, put it in the PM one. Oh, yeah. So, folks, I put the All right, are we good? So, the lesson that you missed, I actually wrote it in the other classes book, but I'll post it for us. Now, it's similar to stuff we're doing today, but if you would like some extra notes, I will post them. We also did look once again at 3 and 5 point sketches. Okay. So are there any questions, folks? It sounds like there are some questions. I'm happy to answer them. Okay. So when I am learning math, I am continuously creating a tool sheet for myself. Okay. It's like a summary sheet. Okay. And what I do on my tool sheet is I write down all the tools that I'm learning and what they are used for. I used to call it a summary sheet, but I really like the idea of like building a toolbox because the whole tricky thing on an exam, it's not can you factor? Yeah, by the time the exam comes, of course you can factor. Of course you know how to use the quadratic formula. Of course you know how to complete the square. The trick on the exam is which tool should I use? Right? So often a student is like, I'm not sure what to do, how to start. So it's more about understanding what your tools can do for you. That's why I like to call my summary sheet a tool sheet. Okay? So the tool that we're focusing on in this lesson is completing the square. Right? So on my tool sheet, I'm going to be like, okay, I got a new tool. It's called completing the square. Okay? What it does. What does it do? Okay, I want you to discuss with the person next to you. The first one you can answer. The second one you might not be able to answer, but I think you can.
I think what it does is
Look in your book if you're not sure.
probably what it's instant.
What do you need to find? Good. Okay. All right, folks. So my group here, well, the group I was eavesdropping on, said, yeah, what it does, it converts an equation from standard to vertex form. Did anyone else say that? Yeah, great. When do we use it? Okay, what would a question say? It would say find. Okay. I'm going to say find AHK. So if it's like, here's a standard equation, what's the horizontal translation? I can do it. I can do it. What's another thing we can find by completing the square? Yeah. Sure. And What's another word, or like if you're doing a word problem and you need to find the vertex, it's not going to say there's an airplane flying, find the vertex. They're not going to say that. What's the word you might read? Say it. Someone said it. Max min. Okay. So for today, I'm going to write it in blue. Find max or min. So specifically for word problems, it is not going to say find the vertex of the football as it flies through the ground, through the air. No, but it's going to say how high up does the football reach? Okay, stop talking. Please. Okay, so we've got a tool. Okay, great. And we know when to use it. So if I get an equation that looks like this, and it says find the minimum value, do I have to complete the square? Why not? Talk to your person. Why do I not complete the square if I get the blue one? Yeah.
Ask the question again.
If you were given the blue equation and said find the max min, why are you not completing the square? Good. It's already in vertex form. Great. So again, it's important to understand when do we use the tool. All right. So let's look at a few problems. Example 1, the height. So as we're reading, folks, do you have your highlighter out? Go get your highlighter. Who needs a highlighter? Anyone want to borrow a highlighter? Okay, Maya, Grace, Alexi, anyone else? Teeny, Sophie. Somehow I'm really good at throwing highlighters. Anyone else? All right. So read the question. Highlight the important information, circle or underline what you need to find. Go through the entire page, read all the sections of A, B, and C. So for the entire page 16, you're underlining the important information or highlighting it, and you're circling what you need to find in each question. Okay. Oh, that's tricky. Okay. So I've read all 3 questions. I see I need to find the maximum height and at what distance that happens. I see I need to find when the rocket is at 10 meters above the ground, and then I need to find out the range of the rocket. So how far can the rocket fly? Now, here's a question. At what height do we know what height the rocket is shot from? Yeah.
0 if it's on the ground and there's no C.
There's no C. Okay, interesting. Yeah, so there's no y-intercept. And that actually gives us a real, right? Watch, look at the equation. There's no y-intercept. So no y-intercept means that at time equals 0, the rocket is on the ground. So do you know what I always do as a physics teacher? I always draw the picture. Okay, so there's some ground. Green grass. So happy. Then I'm going to just put a vertical line for measuring the height. Okay, the green line is for measuring distance. Both are in meters. I'm going to write meters. Now there's a rocket that's flying almost like could be a stomp rocket. It starts on the ground and it makes a parabola because of the gravitational acceleration, right? Gravity forces objects to fly in the shape of a parabola. That is how our Earth works. Okay, draw a dot for where question A is interested in. Question A says determine the maximum height of the rocket and what distance from the launch point that will take place. So what's the point we're looking at? What's the name of it? Yeah, say it out loud. Yeah, we're looking at the vertex. We're called it max min. Okay, question A, we're talking about that point. Okay. I'm mapping everything out. I'm not going to start yet. Question B, at what distance to the nearest tenth of a meter is the height of the rocket at 10 meters? What that means is, okay, somewhere here, we've got 10 meters. How many times is the rocket going to be at 10 meters? Okay. Yeah, that's right. Peace. 2 times, right? It's going to happen once. It's going to keep going up, then start going down, and it's going to happen again. Interesting. So we're going to look for 2 answers for question B. And you know why? It's a quadratic. It's like we're finding 2 roots. It's just at a different height. All right. Question C. What is the range of the rocket? And then we're given a definition. The range is the maximum horizontal displacement or distance that it flies. So the maximum distance that it flies is from here all the way to here, right? So they're saying, hey, how far is that? And do you know what I want to find out? I want to find out this dot. What is that orange dot called in terms of a parabola? It's not the vertex, but it's a special spot. What is it? Yeah, we could call it the x-intercept. We could call it a root, a solution, a zero. Great. All right, so I actually have a map of everything I need to do. This is helpful. So let's get to part A. In part A, I need to find the vertex. How do I find the vertex? What's my tool? What is it, folks? Completing the square. Complete the square. Okay, you don't have to write this tool situation, but I find it helpful. Okay, the equation I start with, negative d squared plus 8d. Okay, this is a regular completing the square, except that I have to factor out a negative 1. Right, I'm just factoring out the negative. And now I'm going to find my number. I'm going to take my 8. I'm going to divide it by 2 and square it. That gives me 16. So I'll go plus 16 minus 16 and close the bracket. -1. Okay, I'll factor that trinomial. I've got my PST. Right, go ahead. So don't copy me because we all know how to do this now, right? So everyone's actively working. Now that I've factored the trinomial, I want to get rid of the square brackets. So I'll multiply -1 times each of these. And so I get that the height is -d minus 4 all squared, -1 times -16 plus 16. Let's add the new information to our diagram. I have the vertex. My vertex is 4, 16. And now let's make some sense of it. So how high up is the rocket? Is it 4 or 16? And how long does it take? How much distance does it take for the rocket to get to the maximum height? It takes 4 meters, right? Notice we're not doing time, it's distance. So it travels horizontally 4 meters before it hits the maximum. Okay, so we can say, therefore, max height and what distance? Max height is 16 meters at 4 meters. What's the wording they used? At what distance from the launch place? At 4 meters from launch place. So when you give me a final answer like this, you're telling me I completely understand the context. If you just say 16 and 4 meters, I don't know which one's which. Okay? Great. Moving on to the next question. B, I'm looking at what 2 points does the rocket reach 10 meters of height? So if my original equation is this, h equals -d squared plus 8d, am I right? Yeah. And if I don't know what to do, I'm going to substitute something. What am I going to sub? What does 10 represent? Yeah, the height is 10 meters. Oh, so I can take that 10 and put it into the equation. So 10 equals -d squared plus 8d. Ah, okay. What do you think I can do here? Yeah, bring the 10 over to the other side. I'm actually going to do the opposite because do you see how my d squared is negative? I don't like that. So if I move the d squared to the left side, it becomes positive, right? So if I move both of them, I get positive d squared minus 8d plus 10. Ooh, it equals 0. Interesting. And Miss Sly said that there are going to be 2 points that satisfy this equation. What is the tool I'm going to use? There are options. Talk to your people. What is the tool? quad formula, or zero product property and factor. All right, are these the tools you discussed? Quadratic formula, factoring with the good old ZPP. All right, can we factor it? Please tell me we can factor it. Please, 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 please. What are the numbers? Because I don't think we can. Can we factor it? Do we get some nice integers? No, we don't. Boo-hoo. All right. So in that case, what's the tool? Quad formula. All right, let's write it out. We've got A equals 1, B equals -8, C equals 10. See if you can remember the quadratic formula. I'm going to write it out here, but see if you can remember it. You might have to write small just to make sure we have space here for everything. Now, I did make actually a mistake here. I shouldn't be writing x because I'm not solving for x. What am I solving for, folks? Good. I want to know the distance. So I should have written d to really communicate to the teacher I'm solving for d. All right, let's sub in our values. Okay, -8 is just 8. Okay, A is 1. All right, so we're just all doing this. We got 64 minus 40. Now, in grade 11, I would teach you how to simplify this radical expression. But for now, we don't need to. We just need to know how to calculate it. So the first distance is going to be 8 minus 24 over 2. And the second one's going to be plus. Folks, what I've just written, is this an exact or approximate answer? Right. Now, for a word problem, do you think I want an exact answer? No, because I want to kind of understand what this number is. So let's get out our calculators and let's calculate an approximate answer. Right, here's a great opportunity to practice using our calculator. See if you can do the whole thing in one go, like just pressing equals one time. See if you remember which equal sign to use. And I think it said to the nearest tenth. So that means 1 decimal place. Yeah, what's the question? No? Okay. Yeah. That's right. So there's a few options. If you use a different one, that's fine. That's fine, as long as you're showing me him giving you an approximate answer. So I press equals only one time in each calculation, because that way I get the most accurate. Whoops, 6. And it is approximate. So like the second one, the 6.4, it's so close to being rounded up. It is so close to being rounded up that I think if you rounded earlier, we might not get the same answer. Yeah.
negative 24 divided by 2. It makes sense like the square root of 24 divided.
Exactly. So what you want to do, so what Zeta's saying is the calculator thinks 8 minus this chunk. So that's why I want you to practice. So the way that we preserve that is by adding some brackets. So I'm saying entire top divided by 2. Try that. You will most definitely get the right answer. Great question. Okay, we got 2 numbers. What do they mean? Look at your picture, add them. What does it mean? 1.6, 6.4. Oh, yeah. 1.6 and 6.4. We found out how far from the launch point the rocket is when it is 10 meters high. Okay, the rocket height is approx 1.6 meters and 6.4 meters when its height is 10 meters, right? You could have changed the wording here, but again, we're communicating the distance I found is a horizontal distance, not a vertical, because the vertical is 10 meters.
So then why did you use the rocket height is approximately 1.6?
Because that is a very big mistake. Thank you for correcting. Goodness gracious, Miss Sly. The rocket distance. Thank you. Maybe I was checking if you're awake. Yeah. Yeah. All right. Lastly, let's look at the last question. What is the range of the rocket? So we've discussed from our picture that we need to find this C, and we called it an x-intercept or a root. Folks, which form of equation do I use to find the root or x-intercept? Standard or vertex? Absolutely, standard. Okay, so I start with this one. I want to find the roots. Well, what's the tool? Yeah, it's the same one. No, it's not. Good call. But it's not. It's even bigger. It's either quadratic formula or factoring. Now,
That's already standard form, right?
this is already standard form. Is this expression here factorable? Yeah. What type of factoring do I do? It's a binomial, so it's just a GCF. Oh, what's the common factor here? Just D. Oh, great. Okay, so let's factor out the D. And I get negative D plus 8. Could I have factored out negative D? Yup. Okay. Now, when we're looking for the roots, what is the height? This is important. Yes. Height equals 0 on the ground. So when it says, when does the rocket hit the ground? The trick to remember is, oh, the height is 0. So now I've got the 0 product property. So watch this. In order for D to be equal to 0, well, D equals 0. But in order for this bracket to be equal to 0, be very careful. Yeah. I'll bring the D to the other side because it's negative. D is to equal positive 8. So we found out the two locations, the two distances when the rocket is on the ground. So this is the start, and this is the end. Right, so if I draw my parabola, it starts on the ground. 8 meters later, it's back on the ground. So how far did it travel? I.e., what is the range? The range is it exactly or approximately 8 meters? Yeah, I didn't round. So I don't have to say exactly. I'll just say the range is 8 meters. No. A range can be just, you don't have to give a range of numbers. You're just saying it can go 8 meters far. Or, yeah, it can go that far. All right. Yeah.
Do you always have a factor, or can you just multiply your vortex x value by 2? Because your vertex is always up on the right.
That's a great question. All right. Ivy had an excellent question, folks. Ivy said, well, if the parabola is symmetrical, and I already know that it took 4 meters to get to the max, can't I just say 4 meters plus 4 meters? Right? Be careful. Because what if the rocket was launched 3 meters off the ground? Well, that would mean the y-axis would start here because it would start off the ground. And in that case, the distance would not be the same. In this case, yep. But I would like you to show me how you got that algebraically. And when I say algebraically, I mean do the factoring. Do the math to show me how you got those numbers. All right, let's, I don't think I want to do this one. Yeah, I want to do this one. So we're doing example 3. All right, once again, we're using our highlighters. Read every question. Ooh, Ivy, what words do you see here? There are some important words here. Folks, we've got an elevated platform. So the golf ball doesn't start at the ground. Okay, what do I need to find? What else do I need to find? All right. So page 18. Let's draw a picture. Whoa. My vertical axis is height in meters. My horizontal axis is what? Good. Time in seconds. And then we've got a golf ball. Does it start on the ground? No. Now, don't worry about the picture. Like, just be like, okay, it starts off the ground, and guess how it flies? Like a parabola. Okay, this is a good enough picture. In question A, we're asked for the max height. So what point are we looking for of the parabola? What is it called? Okay, so this is question A. We need the vertex. What are we going to do? How do we find the vertex? What's the tool? Yeah, complete the square. How about B? At what time does the ball achieve max height? What point are we talking about? The vertex again, right? Max height happens at the vertex. Well, guess what? A and B, it's kind of like the same question. But C is different. C wants to know, when does the ball strike the ground? So where is that point where the ball strikes the ground? Right here. And what do I call this point? Right? If the green point is the vertex, what do I call the orange point? Say it out loud. X-intercept, root, zero, right? All those words. So to find this, I'm going to complete the square. And to find the roots, I can see right away factoring will be ugly, so I'll use quadratic formula. Done. I have done all the thinking that I need to do for this question, all in this picture. Okay, so let's start question A. We're given an equation. Folks, do you see all the stuff that you read ahead of time? A golf ball is shot up by da 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 da. Do you think any of that matters for us? It doesn't, because it's all already included in the equation, right? 4.9 is the acceleration. 19.6 is the speed. And 558.8 is the initial height. But I don't need to know that because that's physics. I'm given the equation. So I'm just going to complete the square. So everyone have your calculator out. We've got decimals here. All right, and let's complete the square. Step 1, square brackets. Step 2, factor out negative 4.9. Negative 4.9. Oh, I think this is going to work out nicely. I think it's 4. Oh, we are so lucky, folks. 19.6 divided by negative 4.9 is minus 4. That's nice. Let's find our number. Let's find that special number. So I take the coefficient of B, negative 4. I'm going to divide it and square it. What's it give me? 4. So plus 4, minus 4. I've got my PST. Okay, I'm going to factor my perfect square trinomial, t minus 2. And now I want to get rid of the square brackets, so I'm going to expand and multiply both of these terms by negative 4.9. And I see negative times negative. Oh, that's good. And 4.9 times 4, I actually know the answer. It's 19.6. All right, this is plus. Squared. So 19.6 plus 58.8 is 78.4. And I'm pretty happy seeing this because it means that the maximum height is higher up than the platform. So let's add this information. We found the vertex, right? It's 278.4. Let's add that to the diagram. So which one is this vertical distance? And what is this horizontal time? Right? 7.4 meters high. And it took 2 seconds to get there. So we can say, okay, for A, they're just asking for max height. Max height is 78.4 meters. And question B, at what time in seconds does the ball achieve max height? We don't even have to do any math. We can just write max height is achieved at time equals 2 seconds. Right? We've done the work in part A. And again, I see it says maximum height, and I'm like, yeah, I needed the vertex to find maximum height. Please.
Why did we write at time equals 2 seconds and not just like it reaches its max height at 2 seconds?
That's fine.
Okay.
That's any kind of wording where you're showing me, as long as you say seconds and max height, you're good.
Okay.
All right. So now we need to find how long it took for the ball to touch the ground. Ivy, tell me the really sad news. Is it going to be 4 seconds? Folks, is it going to be 4 seconds? I just really want to say 2 plus 2. Is it going to be more than 4 or less than 4? Okay. Okay, so we're like, this took 2 seconds. What is this going to take? Let us see. But we know it's not going to be 4. That's just the sad truth. Okay, so if I need to find roots, do I want to work with the vertex form or standard form? Okay. So let's write it out. Negative 4.9 t squared plus 19.6 t plus 58.8. All right. I am not factoring this. Or maybe I should. 58.8 divided by 4.9. Ooh, folks. It's 12. Let's common factor this. Would that help? Negative 4.9. This might make our life easier. Plus 4t plus 12.
Wouldn't it be minus 14 minus 12?
Yes, it will be. I was like, this doesn't look right. Thank you. Minus 4t minus 12. Because otherwise we couldn't factor it, right? Can we factor it now? Negative 6 times 2, right? Right? Negative 6 times 2. I can do it? Someone? Okay. Whew. All right. Negative 4.9. And I can factor it. It's a simple trinomial. So I'm not decomposing. I'm just using the two numbers I found, -6, +2, right? I didn't have to do those two extra lines. Now, I want to say t equals 6. Why am I allowed to say it? What's happening on the left side of the equation? What is happening here, everyone? That's right. Height equals 0. So since I have it in factored form with a 0, I can use the zero product property. And I can say, okay, in that case, t equals 6 and t equals -2. T equals -2. What the heck? What is going on? Do you know what's happening? If I've got my parabola going like this, imagine the parabola goes back. Where would it have the second root? At -2. So it's not like it happened, but that's just the shape of the parabola. So was the ball in the air for 8 seconds or 6 seconds? Did the dotted line actually happen? Did this part actually happen? No, the ball started here. So it was in the air actually for 6 seconds. But if I think of it as a mathematical model, I can say the other root is here. But the ball was not hit at -2 seconds, right? That's just for us to understand that, yes, there are two roots. It's just only one of them represents the real life for us. So we can say the ball, when does the ball strike the ground? The ball strikes the ground at time equals 6 seconds. All right, you have homework for this. Tomorrow, you will be reviewing. There's a lot to review, folks. We're going all the way back to, is it a function or a relation? AHK, completing the square, word problems. So please do your homework today. Yes.